anyone can wiretap anyone with VoIP. So it will be possible for criminals to wiretap the police, or criminals, organized crime, for example, to wiretap prosecutors and judges, and wiretap the rest of us to get insider trading information at companies, to get personal information that can be used for blackmail. The vulnerabilities become intolerable with VoIP. And so while we didn't really need to have encryption for the public switch telephone network, we do need to have encryption with VoIP. So that's why I'm doing this project. That's not the only reason I'm doing this project. I'm also concerned about civil liberties in the US. But anyway, so I've got this project called the ZFone project. It has three things. One, I've developed a protocol that's, that describes how to encrypt a VoIP call. And I've submitted this to the IETF, and it will become an RFC. The second thing is a software development kit that implements the protocol. And the third thing is a product that uses the SDK, and that product is ZFone. Now, the SDK is how I'm actually trying to commercialize this, by licensing it to anyone who wants to build a VoIP client or a PBX or any kind of VoIP product that could benefit from this protocol. And so I'm working with some companies in Europe, some companies that are putting it into mobile phones. It works on the Asterisk PBX, and it can be used anywhere that VoIP is used. So, Mauro, do you have the website up on the screen?
I have your image now, but I can show the website, sure.
Okay. Well, we can. I don't know if you could change it to put them both up. But you can put them up. I guess you can put the website up later, since I don't want to share my screen space with the website.
Right. So we are on the website, the ZFone project. It's on the screen.
Good. Okay. So, so they see the website instead of me?
Right.
Okay.
We can see both.
Oh, good. All right then. So I do a Diffie helmet exchange between the two parties, and we decided to take a different approach for protecting against a man-in-the-middle attack. Normally, normally the way this is done is to build a public key infrastructure. That means build a bureaucracy to certify public keys, and it can be quite complicated. But I decided to do this without a public key infrastructure because I think that a PKI is not the appropriate approach to take for VoIP. My keys are created at the beginning of the call and destroyed at the end of the call. And the two parties can detect a man-in-the-middle attack by comparing a short authentication string verbally. And if it matches, everything is okay, but if it doesn't match, then there's a man-in-the-middle attack. That means there's a wiretap. Right. And so we display this authentication string on the graphical user interface, and the two people that are talking over the secure channel can verbally compare them and see if they are the same at both ends. And if they're not the same, it indicates the presence of a wiretap. So this means you can do it without a public key infrastructure. You don't need to have that bureaucracy. It means that you can get running immediately with very rapid deployment without having to go through the pain and suffering of building a PKI.
Okay, so it is an open source project, right? And
yes, but I'm also licensing it commercially. The SDK will be available under the GPL, but it's also available for commercial use without the obligations of the GPO. But you have to pay money for that.
Okay. What are the main features of ZFone project? I mean, for techies, because we have many students and telecom people here, so you can go into details of the encryption and why is it an alternative to Skype, actually, a better alternative in your point of view?
Well, you know, Skype doesn't tell anyone how their protocol works. And they also, of course, don't publish their source code. I do both of these. So you can review the protocol and see if it, you know, if it's a good protocol. You like the source code and see that there's no backdoors. We don't have that level of confidence with Skype. With Skype, they're just saying, trust us.
That's what we do right now.
Yeah, I mean, I'm not saying that there's a backdoor in Skype. I'll let other people make that judgment. But I'm saying that as a matter of policy, it's just a good idea to insist that you're using open standards, that the protocol is open and subject to peer review, and also the source code should be published so that everyone can see it and see that there's no backdoors.
Very good.
And that's a practice that I did with PGP back in 1991. I published the source code of PGP, and that helped build the credibility of PGP. And I'm doing the same thing now. As far as the technical characteristics go, I'm doing a 3,000-bit ephemeral diffie Hellman exchange. Ephemeral means that the keys are created just for this call and destroyed at the end of the call. I'm using the advanced encryption standard for encrypting the media of the packets. The AES is used in counter mode. It's using a protocol called SRTP, Secure Real-Time Protocol. And the session key for the SRTP encryption that's determined by the diffie Hellman exchange at the beginning of the call.
Okay, so the main benefits is that the people can use a soft phone with a SIP protocol with encryption, and besides that, they would know that someone is listening to them and they would immediately stop the communication, right?
That's right. It's very easy to detect the presence of a wiretapper. But most importantly, to do this without reliance on a public key infrastructure, without depending on any servers, without depending on a phone company, without even the participation of the phone company in the key exchange. The key exchange is only between the two parties that are speaking. The phone company is not involved.
Okay, maybe we can ask to the audience to have some questions for you.
Sure.